Hey, natural science students, I'm recording this today because if you have class on Monday, that means that I'm gone for jury duty. And this is kind of a troublesome day for me to be gone because we are reviewing for the chemical reactions identification and balancing tests, and then you're going to be taking the test during the first and into the second half of class. It's also kind of good that I'm gone because you all need to be able to do this on your own at this stage. So here's what's going to happen. Just to remind you real quickly, I balanced number 3 and number 5 and number 6 on this sheet in large group. Okay, I'd like you to do number 2 and number 4 on your own today. We'll draw a little arrow here. Okay, so you're going to do 2 and 4, but I'm going to do number 1 as an additional practice one. I also sort of want to show you what I'm seeing when we talk about types of reactions for some of these. We only talked about types of reactions for some of them, but I also want to draw some symbols on here to help you a little bit with identification. And so let's take a look at number 1. Number 1 type of reaction. Well, here's what I see when I look at number 1. I see CXHY plus O2 produces CO2 and H2O. Now that's a very specific reaction on our list of reactions. This is a combustion reaction, and we're going to balance it right now. Notice that I have the counting matrix there with the C's, H's, and O's. If it helps, you can draw the line down the middle so you can separate the left and the right-hand side in your mind. Let's start counting. 2 C's, I know that because of the subscript, 4 H's, 2 O's, that takes care of the left-hand side. Right-hand side, 1 C, 2 O's here, plus 1 O here is 3 O's, and then 2 H's right over here. Now remember what our rule is. Our rule is that I would recommend that you balance oxygens last, because oxygens are kind of the jerk of the balancing world, okay? They do crazy things. And so I'm going to start off with hydrogen. I'm going to put a 2 here. This is the side of the equation where we have less of something. And by putting a 2 in this blank, I'm going to multiply it times the subscripts. 2 times 2 is 4 H's. That fixes my H's. 2 times 1 is 2 O's. Plus 2 O's is 4 O's. Now that actually makes the O's a little easier to balance later on, but let's go ahead and fix the C's before we fix our O's because there's going to be another change here in a second. We have 1 C on this side and 2 on that side. So I'm going to put a 2 here. 2 times 1, 2 C's. 2 times 2, 4 O's, plus 2 O's is 6 O's. Once again, we're going to balance the oxygens last. Our C's are equal, our H's are equal. Let's figure out what to do with the oxygen. Well, I got to find a blank on the left-hand side that has oxygens, this one. And I'm going to put a number in this blank that when I multiply it times the subscript is going to give me the number I need, 6. So 3 times 2, 6 O's. Okay? So we're not quite done. Everything is balanced. But there's one last thing that we have to do. Step 5, we got to put a 1 in any blanks that are left over. So that one is all balanced. Now, I want to talk a little bit about identifying reaction types for the ones that we did in large group, number 3 and number 5. Let's see how the general pattern matches these reactions. So we decided in large group that this is a decomposition reaction. Let's figure out how I was able to come to that judgment. So decomposition sounds like decompose. When things decompose, you're splitting one thing into many things. So notice how on the right-hand side of the equation here, I have like an A, a B, and a C, but all those things were combined together into one thing on the reactant side. We'll call it ABC. This doesn't match the general formula for a decomposition reaction that I gave you. That was AB falls apart into A and B. But remember that for combination decomposition, you could have any number of things being combined together in a combination reaction, and you could end up with any number of things in a decomposition reaction. These letters are just designed to help you to track what's coming together and what's splitting apart. Let's take a look at number 5, which we also did in large group. Wow, there's a lot going on here. First thing that we should always do is find the arrow. And once you find that arrow, you're going to sort of take a step back and look at the big picture of what's happening in this equation. And this is a really busy equation. I have sodiums and CO3s in parentheses and zincs and NO3s in parentheses. What's happening between the left and the right-hand side of the equation? Well, the CO3s and NO3s are acting as nonmetals. They're polyatomic ions. And they're pretty much in the same places other than being switched. Look at what's happening to the sodiums and the zincs. The sodium starts bonded to CO3, but then later on it's bonded to NO3. The zinc starts bonded to NO3, but then it's bonded to CO3. So what's happening here is two metals are switching places with each other. What we have here is AB plus CD produces AD plus CB. This is a double replacement reaction. Okay? Double replacement. Two things replacing each other. I'm going to leave it up to you to think through some of these other ones. Anything that you don't have filled out on your review sheet, and the guest teacher should have extra copies of this sheet if you want to work on it. I'm going to need some of you to be classroom leaders on this. Okay? If you understand how to balance, if you understand how to find reaction types, we got to get together into little study groups during this first half of class so that you can feel confident about what's going on. Okay, so I want you to try to do number 2 and 4 on your own, but if you need a little bit of help, this is your last chance for help. Whatever you do, don't give up on the quiz. You can do it. The quiz is rated higher for type of reaction than it is for the balancing, but remember, I promised you that there would not be complex or tricksy balancing on the test, and there isn't. I can give you partial credit just for doing partial steps, too. So if you can even just count correctly each side of the equation, I can give you a little bit of partial credit for that. Now, folks, you're doing the test no matter what, okay? It's not negotiable. And it's best if you just do it now because at this stage, additional practice, well, I'm not sure how much more it's going to help you. We just got to dive right in and you got to show me what you know. Okay? And so I wish you success. I don't believe in wishing people luck because that implies that it's all like it's random. Your success is going to be based upon the decisions that you make and how much you practice. And so I wish you success on the quiz, and we're going to be silent until everybody is done with the quiz. If you're going to take the quiz in AL, that's fine. The quizzes have been dispersed to people in AL, and so go ahead and if you want to go down to AL, you can. And so once again, I wish you success. Have a great day, and I will see you when I come back, hopefully on Tuesday.